All right, welcome back to another Modarra Monday. My name is Peyton Dean. I am the 26-year-old machinist trying to build a high-end bracelet and jewelry company to express my machining love for machine precision parts, little assemblies, and then playing with materials, coatings, textures, patterns, all that type of stuff. So that's what we're trying to do. Last week's episode, we built a fixture. This is where it gets awkward. I am completely changing this design, and I'm going to show why. Someone in the comments caught it in the last video. I was also thinking about it, and I'll explain that in a second. But we were able to salvage a lot of the work that we did last week, so I'm happy about that. Side note, first of all, thank you for everybody that watched last week's video. That one has done the best. I think we're at a few thousand views already, so thank you for all the new subscribers. Welcome. That's what we're trying to do here, like I said a few seconds ago, is build this awesome business. So another thing, thank you to everyone that followed the Instagram. Link in the description. Guys, if you're not already following there, check it out there. I also post clips, and I'm going to be posting a lot more on there as well. Now, to all the armchair machinists out there in the comments, I love you guys, but also just be aware of what you're commenting. Sometimes it is quite ridiculous. I understand I'm not perfect in what I do here, but some of the comments were definitely wild. So, love you guys, but you might just check yourself, that's all I'm saying. Because you guys do look ridiculous sometimes. But I'm very excited this week. We should be off to the races here. I'm going to cut to a clip of me showing you guys some fusion work. I also did see the comments in the last week's video. You guys want me to show more machining, so I'm going to try to do the best that I can with that. There was a few comments that also mentioned, like, what I'm saying out of context doesn't really make sense, and obviously out of context that would make sense. So you got to make sure you watch all the videos to see what we're actually trying to do here, what we're working on. I only spend Sundays working on this business, and then Mondays the videos go live. So this is the only day that I have dedicated to this project. So with that being said, I also heard you guys talk about like some of the ranting. You rather me skip and just show machining. I'm kind of split between that. I understand what you're saying, but also part of this brand is me and the story behind it. So if you guys don't get to know me and how I operate, I would argue that that is more than 50% of the brand, at least right now, is me. So get used to it. I will try to cut down on some of the randomness, but I do want to express my emotions, and also talking to the camera allows me to think out loud. So that's what we got. All right, next clip, let's go. Alright, so this was the current design that we have machined down there. We have our stock standing vertical. We were going to machine this angle for clearance. The problem with this was we were going to make some kind of locking bar that would screw into the fixture. We'd have our set screws here, and that would push into our stock. Now, somebody commented and caught this in the video, and I thought of this already, but I wasn't sure if it would actually be a problem. And the more I thought about it, and I was like, man, I don't know if this is gonna work, because you'd have screws that hold this bar here and here, let's say, and then you're gonna have set screws that are gonna be pushing in, and most likely those set screws are gonna bow this bar out, and in the end there's just gonna be zero clamping force on these actual dowels of material. So we have two options here. It is currently 9:30 in the morning right now, and we can either spend probably an hour or two to machine this bar and to test this theory, or we can completely ditch that method. We could still use this fixture because we have it mounted vertically, and we can do this method that I thought about a long time ago. And of course, it's like this fixture saga at this point, but it's fine because we're learning and we're having fun. And we're getting content out of this. So this is currently the same block on the pallet. It's offset because our stock was offset. Now, I want the stock to be on center. Basically, I'm trying to salvage as much work as we can. So we already have this block that's machined on all sides, and it's already mounted to our fixture. So what we could do is we could take the same stock and we could drill a hole all the way through. Now, this piece of material is, I believe it's right around 5 inches. Yeah, 5.1. So the drill I have is only like 3.5 long. So we'd have to drill from one side, flip it, drill from the other side. Basically what we want to do is we want to create these holes that go all the way through so we could stick a bar all the way down there. Then we could create these relief cuts here so we can get in here and actually machine the parts without having any collisions. And then we're going to drill and tap our holes here for our set screws. And this way, the bar, wherever our stock went, our bar, it will be pushed up. Technically, it'll be like this. If we move this, it'll be like pushed up like that. And there'll be a set screw here pushing it up. Now, I understand it's not a V-block. I understand this is technically 2 points of contact. However, I think this is going to be plenty strong, and this eliminates the flexing problem that we mentioned because this is going to be one solid piece. So the simplicity is definitely here. I like this. There's a few things that we're going to have to think about as far as we're going to have to machine some kind of a hole, maybe a cross hole along this to let coolant and chips potentially flow through, but then also mill maybe a slot down here, because if I start machining these parts and I start pulling this bar up, and if I drop it, and let's say it's half the size, it's going to fall in that fixture. I'm going to have no way of getting the thing out. And if I had a little slot down here, I could at least use like a screwdriver and I could like flick it up and grab it or something like that. So that's kind of what I'm thinking. I think this would totally work, and it's not ideal that this currently is mounted offset pretty far from center line, because center line's right about here, but it will work because we can easily work in this orientation for the, like literally 90% of the machining is going to be in one orientation. The only reason we flip it is to machine, let's see, the tab, literally just the one tab feature, and that's about it. So as long as we have plenty of clearance from here to here, which I know we will, we can even put the one tool in a longer tool holder if we need to. But obviously if this was on center, that'd be more ideal. But my whole point is we can make this work, we can test this theory, and we can save a little bit of time by not having to remount this to the center of the fixture, drill and tap holes, etc., etc. So this is what I'm gonna go with. So now I'm just making sure I like what I have here and going to program this, and then we're going to go downstairs and we're going to machine this. What we're going to do is we're going to take this piece here, we're going to counter bore some bores here, 10 bores, and then we're going to come in and we're going to drill it. So that will be my quote-unquote center drill, is to try to keep this drill as straight as we can. We're going 3 inches down, we'll flip it and run this exact same program. Since we're probing on center, we can do that, which is actually really nice here. I wanted to start with this section here that has our drilled and tapped holes. We are going to be machining into a few of these, but for the meantime, we should be okay. So without further ado, let's go ahead and probe this in, and we're gonna, like I said, take a 3/8 end mill. We're gonna come in here and bore those holes with through spindle coolant, and then we are going to come in here with a 13/64 drill, which is around 406 diameter, and we're going to cut these pockets, or these holes. The carnage. I love seeing ships like this. Alright, so this was the first step here, was boring those holes, and now we're going to come in and we're going to drill 3 inches down. And as you can see, there's quite a bit of chips here. I'm going to have to clean this machine out here at some point. But let's go ahead and drill those holes. Alright, Mr. Drill. So we're going at 1200 RPMs, 1/8 inch peck. yeah, I think this is going to be fine. It's just going to take a while here. All right, well, this is kind of boring, so unless you guys want to watch an 8-minute drilling cycle, I'm going to cut to this. So, a little backstory while this is doing its thing. When I bought this machine, I had automation in mind, and I bought pretty much every option you can get on a VF2. So, I've got the programmable coolant, which I thought was kind of a gimmick product, but it's really nice when you have it. So, I have these controls here that I can adjust coolant up or down, and in my offsets page, so we're on tool 26 right now, we have a coolant offset. So right now it's set to 11. So if you look, this stream of coolant is pointing right there. That's too high up for what we're doing. So I'm just gonna hit the coolant down, and I can angle that down to be more at where the cutting action is. And so that just changed. I have a coolant position up here of 16, so we can go over here and we can input 16, and if I hit F1, it'll update that. So now every time the machine changes to this tool, just this one coolant nose or nozzle will adjust. It's actually really handy because, as you guys probably know, those coolants around the spindle, you manually adjust, and they're not always pointing at the right height. As you can see, I'm blasting the holder right now, which is kind of pointless, but to have at least a few coolants hitting the tool, that's all you really need in this case. So again, I just wanted to mention that is really nice for certain applications. Okay, I've drilled 2 out of the 10 holes. Before we go any further, this is a piece of our stainless steel round bar. I just want to do a sanity check. It does fit. There is slop. The reason we are doing a 406 size hole is it's a little bit larger than 3/8. That way, in case our stock comes oversized, we still have a little bit of clearance. So that's the reason why we aren't just doing a 3/8 size hole. Obviously, go a little bit higher. So we're about 30 thou larger, which is totally fine. So that's why we're doing it. Looks good. Let's keep drilling. Bada bing, bada boom. The holes are drilled. I'm going to touch these with the chamfer tool, flip this, probe it, and we're going to run the same cycle again. All right, I have a hot take. In a situation like this, this is the face that is going to be down on the pallet. So all we need to do is deburr these holes. Yes, I could have added that into my machine, but all I did was grab a 90-degree countersink. I have these, I literally just hold it in my hand and I deburr these holes. It takes me like 10 seconds, a lot quicker than programming it and running the risk of anything, right, in an expensive machine like this. And I think what makes a good machinist, in my opinion, this might be controversial, but it's knowing when to go fast and when to go slow. In a situation like this, it's faster to do what I just did, and there's no tolerance to these chamfers. It's literally just an edge break. You're never going to see it again. If this was a cosmetic side of the part and I was making more than one and it was for a customer, obviously I would do this differently. But you have to identify the scenario that you're in and move as quickly as you can when you can, and slow down when you also can, or you know you need to. So I'm curious what you fellow machinists out there think about that. I think going slow in certain situations is necessary, but when you can go fast and move on. So curious your guys' thoughts. All right, we drilled the first hole. So the hole definitely went all the way through. Yep. So let's go ahead and run it, and then we can take it out and look through the bore and make sure it's just, I mean, obviously it's going to be a drilled finish. We could ream it. I don't think that's necessary though. And as long as it's somewhat straight, that's all I really care about. But let's keep on drilling. So I have to turn on the universal robots because the I/O is set up to actuate my rock lock. So the only way I can take that 5th axis vise on and off is by turning this on and using the I/O on here, which is kind of funny. It's kind of annoying, but I don't normally take the vise on and off that often, and I'm not using the robot, so it's just one of those things. But we'll turn this on and I can show you how I toggle the I/O on the rock lock. Okay, I don't know if you guys will be able to see this. Maybe if I hold it up to the light. I'm actually really surprised at how well this worked out. I think looking at it, the holes matched up definitely within a few thousandths, maybe even better. So I'm very happy with that. I even took a piece of material, put it in there, and like pushed it up to one side to see if I could feel like a step in the center there, and I couldn't. So I'm very happy with this. It's also funny how lighter this is already from all the metal we've taken off. So I'm going to measure a few things, make sure that this is where it is supposed to be, and then we're going to set this up. Actually, we're going to remount it to the pallet, and then we're going to put this in the 5-axis, and we're going to mill some features on it. So we got lucky that the dowel pins still have enough of a surface there, and then our threaded holes are good there, except for this one. I still might thread a bolt into there, and the only downside of these is that's going to remove like 3/8 of an inch that our stock can go down. So that either means our stock's going to stick out 3/8 of an inch longer, or our initial blank size will be 3/8 of an inch shorter because they'll be hitting that on the bottom. But after the first part, it won't matter. So that is something to consider. I could move those over to gain that back, but I think for now that's totally fine. So let's go ahead and put this back on the fixture plate, or the pallet itself. All right, so first step, got to turn the robot on. And then we can go to our I/O, and then we have the rock lock open. So now this should be able to come off, which it does. And we're gonna have to clean this bad boy off. Since I don't use this a whole lot as far as swapping stuff, at least right now, I try to clean it pretty good. It can get pretty dirty and packed with chips. It's actually pretty surprising how much chips can get in there, even though there is a vise sitting in it. So, okay, I'm fine with that. So now this guy, let's see, it would go on like this with the robot, so we probably should stick to that. So now I'm going to go back over to the robot control, hit rock lock off, and this should suck down and be set to go. Okay, I'm going to take this guy out of here because this thing is kind of a beast. Take him out, and then we are going to have to probe this. Yeah, this is exciting. This is looking good. So, yeah, now I got to probe this, make sure it's in the right orientation, and yeah, we should be good to go on the next op. Well, that's not going to work. We got our post working. That took a lot longer than I thought. Now, we should be off to the races here. This is definitely heavier than a cut than I thought I programmed. So with that being said, I'm gonna go double check that. I mean, it's set to 100 now, I guess. Yeah, I guess that's probably 100,000 step over. While we have this open, I just want a sanity check. Okay, so we're supposed to be taking 3/8 off, so that's about right. All right. Let's just keep going, I guess. So we're at 10,000 RPM, 60 inches a minute, 100,000 step over. Hopefully you guys can see this okay. I mean, obviously I gotta run coolant, but... such a heavy cut with our fixture being orientated like this, it sounds pretty solid. So rigidity wise, those 4 screws and the 2 dowel pins seem to be doing just fine. Now again, what we're doing right now, this is only for clearance. So I'm not even doing a finishing pass. I'm going straight to the size I want here. I am doing a cleanup contour. We'll see here in a second on the back edge. There's no real reason I need to do that, but I guess it's kind of a force of habit. Because again, with this being clearance, we don't care. I mean, this is literally like plus or minus 5 or 10. It does not matter. It's just clearance. And if anything, I'd rather be a little bit smaller. Just trying to show you guys at least something there. I think this is a pretty good angle, though. I'm not going to lie. So that's the cleanup contour right there. Okay. So before that moves, let's go ahead and take a look. Perfect. So we cleaned up that edge. Again, that doesn't really matter. But yeah, this is looking good. All right, so now it's gonna flip over. You're not gonna be able to see that, unfortunately. Hopefully this tool's long enough to get in here. This is gonna be kind of tight. Oh boy. That's as low as it's gonna go. And that's as far back as it'll go. So I think we're good. I don't think think you guys really need to see that happen again, so I'm gonna go ahead and turn the camera off, machine this, and I'll come back. You can see what I mean with this not being on the center line. Definitely need longer tool holders to just give us a little bit more clearance, just to make ourselves feel a little bit better. All right, now we're gonna machine a little bore that'll be our new 0 point. So I can just probe the top of this bore and the Z surface instead of doing this top center part. Just a little something I wanted to add on there. Okay, so now we are boring 3 holes for each stick of material. These will be tapped for our set screws. I'm doing 2 up close, pretty much as far up as I can, and then 1 a little bit lower, like an inch lower, just to add a little bit more stability. I'm willing to bet the top 2 is probably all we need, but I figured we're already set up. Let's go ahead and just drill and tap these. I'm boring them with the 3/16 end mill. I prefer boring. I get a more accurate hole size, and I don't have to center drill. And I keep all these end mills in the machine already, so I don't have to swap out for drills and center drills and all that type of stuff. So that's what I'm doing now. This is gonna take a little bit. Through spindle coolant, and we'll come back, chamfer and tap, and then I think that'll be it for this fixture, guys. All right, we got chamfers, time to tap. Okay, fixture is done. Moment of truth. Pre-thread those in. We're gonna have to deeper that edge, but is this piece gonna be long enough? Yeah. So this is what I mean. I can easily drop this and lose it. Let's see here, what's going on? I don't know if we went all the way through with our tap, so I'm gonna have to manually retap that a little bit. So it looks like I didn't go deep enough. I could have sworn I did. So we'll just test this first slot or this first position. Because yeah, I was putting in the set screw and I was like, why is this bottoming out? All right, there's that one. All right, let's do this top one. And again, I'm gonna have to break some of these edges up top. All right, just enough of a chip that would stop that set screw from going in. try this again. All right, there's one. Again, I'm just snugging this right now. Two. Okay, so those are just snug. Now let me actually like give that a little bit of English. Oh yeah. I don't think that's going anywhere. You guys still see that? Yeah. I think that's gonna work. And we can figure out a torque spec, but I think that's gonna work, guys. Yeah, I'm liking that a lot, actually. So here's what I'm gonna do. I'm gonna edge brake this. I might put that tap in a drill and just clean out those threads, go all the way. And then I'm gonna cut some pieces of material and let's pretend to load this up. Okay, so one 3-foot bar gets me 2, 4, 6 6-inch sections roughly. One's a touch shorter. That's just because of the blade width, probably. So in theory, the way I would load this would be, so like that's the long one, so because of that screw. So yeah, this is what we gotta figure out here. Okay, so that's the short one. And this will also be a short one. So the question is this too long from a machining perspective? I know we're starting to get close to our Y travel here, so it's probably best if we actually put in a tool and see how far out we can go. So let's go ahead and do that. Alright, so this is our Tool 22 3/16. This is the tool that we use to do a bulk of the machining on these, is the roughing and all that good stuff. And that's got plenty of room out there. So that's our max Y. So I think we're actually okay, guys. I think if we get this out of here, we get this table closer. So I think this longer length is actually okay. Hey, when you're good with the bandsaw. That was supposed to be 6 inches. It's not bad. So, like that's a long one, and then it'll go in even more over there. So I think we're fine. The question is obviously this is more rigid than this because it's sticking out probably another 1/2 inch, but I don't think that matters in this case. I think we're fine. So what is the rough number here? Call it 1 3/8. It's sticking out. So if that's our number, we're gonna have to make a little fixture, maybe a 3D printed thing that goes under here that we can push all the stock up against this ledge and then tighten them down. But let's go ahead and let's put some set screws in. Now, one thing I don't like about these set screws is I don't know if they're metric or inch for the hex. Metric is sloppy, inch is also pretty sloppy, and I don't want to strip these. So I'm curious if McMaster sells some with like a Torx pattern or something, because I just know that these are going to strip. Now, one other thing I do want to show, I can show you on this piece of material here. I think this is going to be extremely rigid. I don't know if you're going to be able to see this. You're going to have to trust me, but there's some pretty good bite marks from the set screw, and I think that's acting almost like a Talon jaw. So yeah, so we definitely need a little printed something or other to set the length. I guess for now we can probably just use a yeah, I definitely want to make a little fixture. So that's something we can work on. But in the meantime, I'm just going to thread these in. So I think I want to get Torx pattern or some other drive for these set screws, and then shorter. There, you can see a little bit long here. These might be good for the smaller stock when we plan to make the screws, but for now, they are kind of a clearance risk. These are 1/2 inch long. We probably need 3/8 or probably even 1/2 inch or 1/4 inch. I think this is going to work though, guys. Make sure that that's in the frame there. Yup. Now the other thing that I'm curious if anybody has some good links to where I could get steel instead of McMaster. Love McMaster, but I just know that it's not the cheapest. It would be really nice to get this pre-cut to 6-inch lengths. Another thought is finding like a Swiss shop with their remnants and their drops, if they have 3/8 material that I could buy for cheap. So if you guys are working at a Swiss shop and you have remnants in 3/8, I'd probably be open to buying almost any material. It is nice loading this when it's at 90 degrees here, because I don't risk losing the bar in the fixture. I guess with this being the first bar, that's not really a risk. So I'm just snugging these, but I definitely want to make a fixture to make sure they're all at the same length. That's going to be pretty important, so we can do an initial facing pass to kind of cut them to length more or less. All right, those are just snug, and I'm very happy with this. So I'm going to put in the rest of the screws. Actually, maybe not. It's kind of a waste of time. So let's see. I kind of want to go design and print that fixture real quick. That wouldn't take that long. I might go do that. Okay, I made a 3D printed jig. It fits on there, and we can slide these out, and it should be 1 3/8, which is what we want. Yeah, this is sweet. So I can just hold this. Some of these are still tight. So I did this, and while I was waiting for this to print, it took about an hour, I actually programmed and patterned to machine 10 links. So we're gonna go for it, guys. I want some significant progress this week. What's nice is I can actually rotate these and I can see if there's like a high edge or not from the bandsaw. It's actually really nice. Okay, so we'll hold that. And we can just go in and snug down just one screw at least. And again, in full-blown production, a pallet will be running while we do this offline. Because this is a little time consuming. Okay. So yeah, those are all snug just on one screw, but I love that. I think that's good. Okay, let's double check this. It's a little long. Yeah, I did notice that this side felt a little, I don't think I was pushed up all the way on this side. Again, this probably doesn't matter, but I'm just learning my own process, right? Yeah, the print's actually a little crappy on this one end. I just see a gap there. So we'll go for it. I added a facing pass before the pattern. Learning a lot about patterning in Fusion. I've never really done that too much. I did that when I was machining the prototype links for this bracelet, but it's been a while since I've done that. That was like last October. Okay. So now I can snug these up. We should be able to probe our bore and we should be able to run this. So let's go ahead and go for it. So I probably should use a larger tool to base this, like a 1/2-inch end mill, and I could do it in one pass. It'd be faster, and this is just a lot of wear and tear on this tool that we're using for finishing later on. But again, fail fast, figure it out, prove out the process, and then we can go from there. And of course you guys can't see anymore. So here's a good example of where I think we could save a lot of time if we made one continuous tool path to do what it's doing now. So there's not all these retracts. I mean, that would be, if there's 5 per part, let's say, it's probably more. Let's count the next one. Here we go. Let's see. So that's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 just in the roughing. If we did one continuous tool path, that would be 8 like drop down cut instead of 80. That has to save some time. And same with this finish. This is a finish cut. We could just do one continuous finish cut. So stuff like this, I'm just wanting to take mental notes of now, because this is going to save a lot of time here for us. All right, let's see, what are we doing here? We're just facing the back. So yeah, I'm trying to think of everything I can that would speed this up, because we really got to be able to make these pretty quickly, like I've been saying. It's not from a, oh, I got to be extremely profitable, but a bracelet's going to have like 50 parts in it. And even if I sell it for $500 or whatever it is, I mean, that's only $10 a part. There's a lot of work that's going into these parts. A lot of labor on top of the machining time. So I just got to make sure I can get the hourly machining rate to something that's not like $40 an hour. Okay, so we're facing those off. Do you guys like the commentary as we machine? All right, what are we doing here? Okay, so yeah, we're doing this roughing again. I think that alone, 1,000. I think that could save 3 seconds per link easily with the retracts like we're doing right now. 3 seconds per link per side, so that's 6 seconds per link. 6 times 10, 60 seconds. That's it. I think we could at least get a minute off this program from doing that. Plus the finishing, maybe a minute and a half. But you can see we've got a good amount of clearance. This isn't the longest tool holder, you know, so, but I'm pretty comfortable with this. And this is on the lower side of the fixture, right? So I'm pretty happy with this, actually. Okay, I'm gonna let this run and I'll come back when we're doing something cool. All right, this is looking really cool. I am noticing a handful of chatter on some of these. So we'll have to take a look at the tool here. But again, we're really trying to test out the tool paths, the strategy, the fixture. Maybe these aren't tight enough. Maybe there was just an aggressive load. I don't know. I need to look into that, but we're just going to keep machining these so far. But this is what we got so far. All right, here's a great example. This fixture was just 180. We chamfered the parts on that side just fine. Plenty of clearance. Now with it being a few inches lower, it's chamfering here. By the time it gets over there, I don't know if you can see that. That sheet metal would definitely crash into the probe. So I'm gonna pull this tool out and put it in a longer tool holder. Even something just like this would make a huge difference. So let's go ahead and do that. Okay, I went with a way longer tool holder just to be safe, and it was open. So hopefully the run out is fine on this. This is currently the side that's already been chamfered. It's just easier if I rerun this real quickly to get to the next part of the program. So I don't want to have to repost right now. So this is all air cutting right now, and it'll flip and we can check that clearance. But I'm glad I caught that, because that was a scenario where it started all the way over at the left and worked its way to the right. Normally it's right to left, and I can see that probe like right away. So long story short, always check your clearances. That is the one downside of having the probe all the way over there, but it is what it is. So I'm glad we caught that. Right now it's just kind of spot chamfering the link hole where the screw goes. All right. Now Oh yeah. I don't know if you can see that, but we're gonna be every bit of 2 inches, if not more, above that probe. I'm also keeping track of my cycle time here, even though I keep stopping it. Hopefully that's not chattering. We'll take a look here after it's done. I love the clearance this gives, but if it gives us chatter, we're gonna have to stub up a little bit. We have the space though. Yeah, that's plenty of room over the probe. But it does give me peace of mind. All right. Isn't this gorgeous? Ignore the one that already fell off because my depth was wrong. Look at that, guys. That is amazing. So it originally was set to 0 stock to lead. That's why the first one fell off. Then I set it to 10 thou, and the tab was too thick. Now it's at 5 thou. They're still very rigid. So I'm tempted to go down to like 3 thou. I'm just trying to figure out what's the best course of action to get these things off. So, because if you guys remembered our problem last time we did this, is we don't want to tear out this material. So, yeah, I'm trying to think what's the best option here. I'm going to think about it. I'm going to go eat some dinner. It's getting late, but I definitely want to finish this before I end the video. Okay, so I just added a contour toolpath. I don't know if you can see that flat line that I just machined. So that gave me a little bit less material there, but it allows these to flex way more. So I'm just kind of whittling away at that material. But what also is nice about this is this will give us a good reference edge with our little fixture. When we go to pull these out, we can set that as our new top of stock, basically, and that will just get all this like weirdness will get machined away. So I'm gonna try to break one of these off here. I'm curious to see where it gives. Okay, that's good. That's what we want. We want it to be breaking down there. Now I just got to be careful because this is going to be very sharp. Okay. So this is definitely better than the part like getting chipped out, if you will. So again, we still have to figure out our Op2 fixture setup, but guys, we just machined 10 links and I think the total cycle time was right around an hour. So Fusion's definitely off, but I was able to reduce at least 5 minutes of that by increasing lead in and lead out speeds while this was running. So, I mean, we're at an hour now. It might be like 50, less than an hour, a couple minutes shorter with the updates. But I am going to do a bunch more updates. So let me flip the camera around here. All right, first of all, how sick is it what we just did? I'm so happy that this worked out. I understand we had some fixturing problems with the first design, but this design I think is going to be awesome. There's a handful of adjustments I want to make, so I took notes on my phone and I want to go over all of these things that I'm going to be changing in the future here. So first step, I need to order end mills. I need to order some 3/16 end mills, find a good brand that I like. And then we also want to order some 9/32 end mill. Those are about 140 thousandths of an inch diameter. It's a little bit larger than an eighth of an inch. And the reason why I want those is I want to increase the cycle time, decrease the cycle time. And this little slot here, we currently machine that with an 1/8 inch end mill. it's slow, and I think it could be increased by getting a little bit larger of a tool. And I think if we just do, instead of an adaptive, I think if we just do something like this, or since all the links are lined up, we just do long, you know, just do a simple 2D contour with a sketch with a line, and just slot this 140 thou. Our width of our slot's 150. That leaves 5 thou on each side, which is perfect for a finish cut. Then we can come in there and do our finish cuts, cut our edge chamfers. It'll be perfect. So I think that'll speed up that part of the cycle a lot. Set screws and or shorter little torque screws. I also realized for this fixture I could use like low profile cap screws if I really wanted to, but the drives on these, again, they're so sloppy, and I know they're gonna strip, so I need to figure out something better for that. Technically, they don't need to be shorter because we had no clearance problems on this, but it would be nice to have them a little bit more flush. So I want to find a better drive though, so that's something I need to look into. Let's see. Programming some different patterns into this as far as toolpaths go to reduce cycle time. Again, with a lot of some of these operations, we're going down, cut, up. Like we're doing this like 8 times here, flip it 8 times here, and then finish passes. Again, I think I could save at least a few minutes off the total cycle time by making one continuous sketch and doing it that way. I understand the concern with that though is now you can't really control that variable, because right now it's per link is the designed toolpath versus this. So I need to weigh these options. At least for a roughing though, I think this would be fine, because we rough 8 times, we go down rough, and then we do a finish pass. So I think at least for the roughing, we could just do one continuous sketch, and then the finishing we could leave individual, so we have that controllability on the final dimensions. So I think that would work. Let's see, roughing and finishing tools, we definitely need to dedicate a 3/16 rougher and finisher. We're using so much of this 3/16, I can just see in the future I'm gonna be frustrated with surface finish, and I want to basically just have a finishing surface finisher, finishing end mill, that will do the walls of this, and then we could use the end of the end mill for this, which is actually perfect. So we could use one finishing tool, use just the sides for this and just the ends for those 2 surfaces, and then a rougher to do the rest. A lot of roughing. Do that. Then changing that first toolpath on the facing, I don't need to be using the 3/16 end mill. I could use a 1/2 inch end mill. I actually already have one, I think, set up in a tool holder over here. Yeah, this is what I had in the machine, but I just took it out. So using something like this to come in and simply face the top of that stock just to give us a good reference plane, do that in one operation instead of 3 little paths. Again, using a smaller end mill, it's just time saving, and that way that can be a dedicated tool for that operation. So that's another thing. Let's see, and then finding a different internal deburring tool. There's some little burrs on the inside of these links that I want to figure out. The other thing that I haven't mentioned in the previous episode and in this one yet is I sent out some links to get electroplated. So I'm very curious to see when those come back. I'm willing to bet I'll have them this week, and I can show you guys next week. So that will kind of start to blend into the surface finish and how are we going to actually finish these parts. So I'm very hopeful that this is going to work. Shout out to, I can't remember who commented about electro polishing. I think it'll work really well. I'm very excited to see the finish and quality of them. So that's also something that we've got coming next week. And then I would like to think we are to the point where we could at least do op ones of these links. I just don't think I want to go, I don't think I want to get into production yet. I feel like that's foolish. So I think we will continue to figure out what our op 2 fixture is. We will dial in this program. I'll probably do that, but I feel like next week we should skip straight to screws and machining screws. I think getting that under our belt will be good, because I can easily tweak this program and we can just test it when we go to do production. I'm not too worried about that. So I think it's minor tweaks of the link program, which is what we were working on, op 2 fixture, and then I think next week we could use the same fixture to do the screws. So And yeah, once we get screws, I wouldn't be opposed to making a handful of screws and links at that point, because the clasps, those are kind of their own separate pieces. So yeah, I think if we could get screws dialed in next weekend, get those good, because now we have links that we can test those with, because these are as close they're going to get to production links, and go from there. So yeah, I mean, I'm very excited with the progress. I'm very excited with all of the supporters. By the time you're seeing this, we have almost 200 Instagram followers, so thank you guys so much. Make sure you guys drop a comment. I love reading them. I love if you guys just have something to say, even if it's just, hey, cool video, whatever it is, just drop a comment. I really appreciate it. And I think we're making really good progress. So I'm very excited. Thank you guys so much for watching Modarra Monday. Again, I'm Peyton Dean. We are building an awesome CNC machined jewelry company for those that want to wear something that's precision, that's not mass produced, and something that's really cool. So that's what we're working on. All right, guys, peace out.